Okay, so to tie up a loose end from the previous episode, we were talking about an ambiguity error that comes with multiple dispatch and function overloading, right? And so what? So I'll give an example and an easy way to think about it that I think is pretty clear. Okay, so what's going to happen is, okay, we're going to have two arguments to our function, to our example, right? And again, we'll talk about cars and civics. And in this case, we'll also add a more specific civic, like a civic hatchback. Okay. All right. So now we have a car is the grandparent, and then the civic is the parent, and then the civic hatchback is the child. Okay. And it's not super important, but I think just having a third class can provide more examples. Okay, and so we're just going to have two arguments, and the function we're going to do is crash. Okay, so for example, if you have a crash function implemented on a car and a car, then that's a car crashing into a car, and that's all we'll do for our implementation is we'll just print a car is crashing into a car. Okay, and then, if we overload or make another multiple dispatch implementation of crash, and we have a civic as the first argument and a car as the second, then in that case, we would just print a civic crashed into a car. Okay? So, a pretty straightforward function. It's just a function called crash, and then, the first argument, it says that is crashing into the second argument. Okay, so no biggie. All right, so now the question is, how do we figure out which of those implementations is going to get used for different arguments? Okay, so I'll give you a couple examples. Okay, so let's say we've only implemented a car versus a car. Okay, now if you pass a car and a car, then of course it's going to use that implementation. Okay, because it's the exact one. Okay, so let's say again we've only implemented a car and a car. And now all of a sudden we pass it a civic and a civic. Well, since the only implementation we have is for a car and a car, it will use that one, right? Okay, so now now that we're kind of getting into the example, I'll give you a kind of a mental model and like a visual for how to think of it. Okay, so I like to think of it as like a little matrix, okay, in which the first argument is the rows, or you can do the first argument being the rows or the columns, it doesn't matter, but I'll just call the first argument as the rows. And then the second argument is the other one, and so for our case, it's the columns, okay? So first argument is rows, and then the second argument is columns, right? And then I also like to think of, for each row is the types, and each column is the types. So in our example, when we have a car, a civic, and a civic hatchback, that means for each row and each column, we have 3 rows or columns. So we sort of have a 3x3 grid or 9 spaces. And so what that means is we have 9 potential implementations that we can make, right? For example, we can do a car and a car, or we could do a civic hatchback and a civic, or a civic hatchback and a car, and so on. So there's those 9 spaces that we can patch in. And the question is, and the ambiguity comes in based on, okay, well, let's say you haven't implemented all 9. Then, given whatever arguments you pass in, which of those implementations is it going to choose? Because it's sort of like a little patchwork, right? And it's like, well, which one is like we said, which one is the most specific? Okay. And I'll give a couple more examples, and I'll give you the way to think about it. So let's say we've got the car and the car implemented, and we've got the car and the civic and the car. All 3 of those are implemented. So it's basically the top left corner. So it's the very top left corner, and then row 1, column 2, and then row 2, column 1, right? It's just kind of those 3 in the corner. And now the question is, okay, what if we call the crash method with a civic and a car? Okay, well then it's just going to choose the second row, first column. Or if we pass in a car and a civic, it's going to choose the first row, second column, and so on, right? But the ambiguity comes when you pass in a civic and a civic. Okay, well, that's row 2, column 2. So which one does it choose? Is it the civic and the car more specific, or is the car and the civic more specific? And the answer is neither. Okay, so I think most languages, they throw up an ambiguity error on that situation because it doesn't know which one to call. Okay, and so what I'm gonna give you here, and I think that's a nice way to handle it. That's fine. So what I'm just gonna give you here is how can you tell which one will it choose, and if it won't choose, how do you also know when it's going to give you an ambiguity error? All right, so here's the key. All right, so we've got a 3x3 grid, so we have 9 spots available, right? And then let's say you call it at a certain place in that grid, right? So, for example, if you call a Civic hatchback crashing into a Civic, that's row 3, column 2, okay? And so basically what you do is you find the spot in the grid at which you're calling the function. So again, in this example, it's row 3, column 2. And you just take that spot and everything to the left of it and everything above it, assuming that the parent type is on the top left, or the grandparent is on the top left, and then the baby is on the bottom right, okay? So like in our example, the car is on the top left and civic hatchback is on the bottom right, okay? So what you do to determine the implementation is you find the spot in the grid corresponding to what you're calling it with, and then you keep everything that spot to the left and above, and you just trash everything to the right and below, okay? So again, in our example, if we're calling it with a civic hatchback and a civic, so that's row 3, column 2, then that basically just trashes the whole right-hand column. So now we're left with 3 rows and 2 columns, right? Okay, so we'll just do another practice on that step. Okay, what if we call it with a car crashing into a Civic hatchback? Okay, well, that is row 1, column 3, right? So we keep everything there and to the left and above. So since it's row 1, column 3, well, we're just basically going to keep row 1 because everything to the left and above, inclusive, we're going to keep. And then everything below and to the right, we're going to trash. So there's nothing to the right, and there's 2 rows below, so we're going to trash those, okay? All right, so now we've practiced that first step. So now that we know where we are, and we've trashed everything to the right and below, that means the one we are actually wanting is in the bottom right corner of whatever we have left, right? Okay, so obviously if that spot is implemented, then we're going to choose that one, okay? And the question is, if that one is not implemented, which one do you choose? And the answer is you look for, okay, so let's say you fill in all the spots that are, or like in a drawing, let's say you fill in all the spots that are implemented. You look for a spot that is below and to the right of all other implementations. And if something like that exists, then that's the one to use. And if something like that does not exist, then you have an ambiguous situation, okay? And that's the answer. It's that simple. So you find the spot, you throw away everything below and to the right, and once you've thrown all that away, now you look to see if there's a spot that's implemented that is to the right and below everything else, inclusive. And if there is, then use that implementation. And if there's not, you throw an ambiguity error. Easy enough. And then we also, just to make sure this fits with our previous idea, didn't we say that, if the exact one you're calling with is filled in, then use that? Does that also fit with this pattern? And the answer is yes, because you throw away everything below and to the right, okay? And now you're left with your everything to the above and to the left, inclusive. And so the one you're calling is the very bottom right corner. And if we know that one is implemented, then that thing has to be below and to the right of all the other implementations. And if that's the case, then you choose that one. Okay? So easy enough. Let's do one more example, okay? So let's say we're again in our 3x3 case with car, Civic, and Civic hatchback. Okay, and let's say we've implemented those top left three again, and then let's also implement the top right corner. Okay, so we sort of have like we have the whole top row filled out, and then we also have in row one in row two we have column one filled out. So we've got that top left corner, corner three, and then one on the top right. Okay, so now the question is, which calls are ambiguous and which calls are not ambiguous, right? And the answer is you just have to use our method, right? So let's try a call on the bottom right. If we try a call on the bottom right, then can we throw away any? No, because there's nothing exclusively below or to the right. Okay, so we're not throwing anything away. And now we look at what's remaining, and we look to see if there's an implementation that's below and to the right, inclusive, like ties are okay, of all the other ones. And the answer is no, because like we said, we sort of have that like L shape, okay? And then, so that one's ambiguous. And the same thing happens if we call anything on the bottom right square, right? So the very bottom right is ambiguous. One to the left of that is also ambiguous, row 3, column 2. And then row 2, column 3 is ambiguous, and then row 2, column 2 is ambiguous. So everything is ambiguous except for if it's in the very first row or in the very first column. Anything in the first row or the first column is good to go. Okay? So that is our explanation of the ambiguity that can happen with multiple dispatch or function overloading. Hope you liked it. Thanks.